Alright, so here we go.
X minus
So first off, I'm looking at x squared minus 25 equaling 0. So x squared equals 25, so x equals plus or minus 5, and my denominator is 0. So that tells me then that the domain of this function is all real numbers, but x cannot equal plus or minus 5. And I can write it like that just fine. My vertical asymptotes then are x equals negative 5 and x equals positive 5. I have to write those separately. Okay. Then it went on to say, go to using logic for end behavior and exponential behavior. Okay, so end behavior first. As x approaches positive infinity, what is, oops, it's not f, it's g. What is g of x going to do? And as x approaches negative infinity, what is g of x going to do? Okay? So if I put a super huge positive number into that function, I'm going to get a positive number on top divided by an even bigger positive number, right? Because if I square infinity, it's a lot bigger than just infinity, even when I subtract 25 from it. So that's going to go to 0 from above. If I switch it around and I go to the negative side, now I'm going to have a negative number divided by a positive huge number. Because when I square that negative number, it's going to become positive. When I subtract 5, that's like taking 1 grain of sand off the beach. Okay? Not really doing much. So that's going to 0 from below. Questions on that? Okay. Now I've got to deal with my asymptotal behavior. So this is going to be as x approaches negative 5 from the left, what is g of x doing? As it approaches negative 5 from the right, what is g of x doing? As it approaches positive 5 from the left, what is g of x doing? And as it approaches positive 5 from the right, I think I said right there for both, but the top one was left, bottom one was right. What is it doing? Okay. So let's drop a little logic on this. Okay. I've got negative 5 there. I've got positive 5 there. Okay. I'm going to take the outsides together because those two are dealing with the same numbers, just positive and negative. Okay? So if I'm thinking about this, I'm thinking about negative 5.1 here, and I'm thinking about positive 5.1 there. Okay? So when I use into my function, remember my function was x over x squared minus 25. If I'm using 5.1, okay, over here on this side, that's going to be 5.1 divided by some number. Now, 5.1 squared, since 5.1 is bigger than 5, 5.1 squared is going to be bigger than 25. Okay? So something bigger than 25 minus 25 is going to be positive, but it's going to be small. It's going to get closer and closer and closer to 0. So a positive number divided by a positive small number sends this off to positive infinity. If I go over here to negative 5.1, that's going to be negative 5.1 over, the bottom is going to be the same because when I square it, it wipes out the negative. Now I've got a negative divided by a positive. That's going to go down to negative infinity. Now let's deal with the insides because those numbers are the same. Negative 4.9, positive 4.9. Okay? So if I have negative, or let's go with the positive one first. So this would be 4.9 over, now 4.9 is smaller than 5, so 4.9 squared is going to be smaller than 5 squared. Okay? So something smaller than 25 minus 25 is going to be a negative small number. Positive divided by a negative is going to be, go down to negative infinity. Negative 4.9 divided by, again, something, a negative small number, is going to go shooting up to positive infinity. Okay? So, as I approach negative 5 from the left, I go to negative infinity. As I approach negative 5 from the right, I go to positive infinity. As I approach 5 from the left, I go to negative infinity. As I approach 5 from the right, I go to positive infinity. Okay? So that is a quick synopsis of the asymptotal behavior and the end behavior.
That's the reason why you have 4 asymptotal behavior.
Because I have 2 vertical asymptotes.
Because it's a square.
Because I have 2 vertical asymptotes. Not every square in the bottom is going to have 2.
Why have 2 again?
Because there were 2 spots where my denominator was equal to 0.
Oh, okay, so x cubed negative 5 over 5.
And that would give me denominator is equal to 0. With me? Okay. So, we got our function, our rational function. Okay. We've got f of x equals p of x over q of x. Okay. What did we learn from yesterday's step number 1? Which side note before we get going on this? Yesterday I told you you should make yourself a note card. One side of your note card is going to be the 8 steps that we have. Okay? So I don't care how you orient your note card, but one whole side of your note card is going to be the 8 steps. Okay? So how I want you to do that is I want you to leave yourself a space on top, and then underneath that, step 1, step 2, and so on. Leave yourself a space on top, step 1, step 2, so on, depending on how you orient your note card. I don't care. The other side of the note card is yours to put stuff on there. So like yesterday, for vertical asymptotes, set the denominator equal to 0 and solve. Okay? Today, you're going to add stuff to the back side of your note card. Okay? Again, That's the backs where I'm filling out your note card for you. Okay? All right? So that you are all set and ready to go. Okay? Understand? Okay? So, step number 1. Find any and all vertical asymptotes. Yesterday we said find the domain, all that fun stuff. Same thing. Okay? Remember, vertical asymptotes occur at values of x where q of x equals 0. We said that already. That's where our denominator is 0. Okay? What else should I know about vertical asymptotes? Anything else? Maybe what they look like, what form they take. Anybody remember? Matt? The dashed line. Okay, so if it's on the graph, it's a dashed line. If it's not on the graph, if I'm just listing it, then what? All vertical asymptotes take the form of, not a fraction, no. Man, we only had notes to look in, people, from yesterday. All vertical asymptotes take the form of, when they're not on the graph, they take the form of x equals some number. How do we find that number? Matt?
You have to find the domain restriction.
The restrictions of the domain. Yep, we find it by finding the restrictions in the domain. Okay? Good with that? Anything else we need to know about vertical asymptotes? How many can there be? How many vertical asymptotes can there be? Many, right? As many as needed, right? As many as the restrictions give us in the domain. Okay, so there can be multiple vertical asymptotes. Okay? Today, what do you think we're going to switch to today? We're going to go horizontal today. Yesterday we were vertical asymptotes. Today, step number 2 is we're going to find the horizontal asymptotes if it's possible. Now, the cool thing about, actually there's two cool things about horizontal asymptotes. The first cool thing about horizontal asymptotes is that you've already found them. Okay? It comes from your end behavior. Okay? What the function is doing at the infinities is it's approaching the horizontal asymptote. Okay? And the only place that I am concerned about the horizontal asymptote is at the infinities. Okay? I don't care about the horizontal asymptote anywhere in the middles. I just care about the horizontal asymptote at the two infinities, because that's the end behavior. It tells me end behavior. Okay? Now, horizontal lines are y equals. Okay? So all of our horizontal asymptotes are going to be y equals some number. Okay? The second cool thing about a horizontal asymptote is that there can only be one or none. That's it. That's your two choices. You're either going to have one horizontal asymptote or you're not going to have any at all. You can't have two. You can't have four. One or none. Okay? We find the horizontal asymptote by comparing the degrees of the numerator and the denominator. What's a degree? Even more.
The highest.
The biggest exponent. Yep, it's the biggest exponent. Degree is the biggest exponent. So you're going to look at the biggest exponent of the numerator and the biggest exponent of the denominator. So you're going to be comparing two numbers. Okay? Now, when you're comparing two numbers, what are your three choices of outcomes? Okay, I got a number on the top and I got a number on the bottom. What are my three possible outcomes that I can have when I'm comparing two numbers?
Higher.
Which one? So top could be bigger. Okay, what's another one? That's one of the three.
Lower.
Bottom could be bigger, or they can both be the same. Okay? So option number one, top is bigger. If the top degree is bigger than the bottom degree, there's no horizontal asymptote. An example. Oops, I put y. I should put f of x. F of x equals x squared plus 4 over 2x. Degree on the top is 2. Degree on the bottom is 1. Top is bigger. No horizontal asymptote. Okay. Option 2. Bottom is bigger. Okay? That's like ones that you've been doing. F of x equals 4 over x minus 2. If that's the case, your horizontal asymptote is the line y equals 0, which is the x-axis, which is what you've been doing up until this point. Okay. Third option, if they're equal. If the top is equal to the bottom, so for instance, f of x equals 2x squared over 3x squared plus 4. Okay, degree on the top is 2, degree on the bottom is 2, so then our horizontal asymptote is y equals a over b, where a and b are the lead coefficients of the top and the bottom. So in this case, the horizontal asymptote in this green case would be y equals 2/3. Okay? Now, this information should probably go where? On the back side of your note card. Okay? Front side is steps, back side is extra stuff. This should go on there. Okay? let's dive into one. Okay? So, find the domain of the function and identify any horizontal or vertical asymptotes, and then do end behavior and asymptotal behavior. Fantastic. We can handle that. Okay? Let's do number 1 together. You can do number 2 on your own, and then we'll come back and we'll do it. Okay? All right. So, domain of the first one. All real numbers, but what? Can it equal -2? Yeah, it can equal -2. Can it equal +2? No, so just +2. Okay? Cube root both sides, add 2.
How did you, the other one, remember that we got 5 and -5, and I sold it for 0 and it came out to be just 5.
You forgot to take, you just took the principal square root. And remember, when you're taking an even radical or an even root, you have to add plus or minus. Here I took a cube root, which is an odd root to both sides, so I don't have to add that. Okay? Then it gives me a vertical asymptote of what? X equals 2 then is my vertical asymptote. Okay? So, horizontal asymptote now. Let's look at that. What is the degree of the top? 1. What is the degree of the bottom? 3. Which one's bigger, top or bottom? Bottom is bigger, right? So top here is less than bottom. That tells me y equals 0 is my horizontal asymptote. If its top is less than bottom, it's always y equals 0. If its top is bigger than bottom, it's always none. Okay? If it's same over same, then it's always y equals the coefficients. Okay? Handle that. Okay? So, now we said, let's do end behavior. So, as x approaches positive infinity, my function here is going to 0. Right? Because it's going to my horizontal asymptote. As x approaches negative infinity, my function is going to 0. Again, approaching my horizontal asymptote. Now I just got to figure out if it's from above or from below. Okay? So, let's look at our actual function. Our actual function is that if I put in a really big, huge positive number, right? Okay? So if I put in a positive number, 4 times that is still going to be positive. Correct? Okay? If I put in a huge number and subtract 2, that's still going to be a huge positive number, right? And I cube it, that's still going to be a huge positive number, right? Okay? So that's going to be a positive divided by a positive, which is positive, right? So this one is going to approach 0 from above. Okay? Now, let's go the other way. Now we're going to put in a huge negative number. Okay? 4 times a huge negative number is going to be negative. Right? A huge negative number minus 2 more is going to be a little bit bigger huge negative number. And I cube it, the cube of a negative is what? It's still negative. Okay? So I've got a negative divided by a negative, which is positive. So this one also approaches 0 from above. Okay? Now we got to figure out our asymptotal behavior. As x approaches 2 from the left, what is my function doing? And as x approaches 2 from the right, what is my function doing? Okay. So now, here's 2. Right? Okay. My function was 4x over x minus 2 quantity cubed. Right? Okay? So, coming in from the left, that would be like 1.9. Right? Okay? 4 times 1.9 is 7.6. 1.9 minus 2. Negative 0.1, right? Negative 0.1 cubed. It's going to be negative, right? And it's going to be small. So a positive number divided by a negative small number says that this one is going to go shooting off to, oops, excuse me, wrong way. Going to go shooting off to negative infinity. Okay. Now, let's come in from the other side. 2.1. 2.1 times 4 is 8.4. 2.1 minus 2. 0.1. 0.1 cubed. Positive, right? But really small. Positive number divided by a positive small number is going to be, it's going to be positive. So it's going to go shooting up to positive infinity. So my asymptotal behavior then here becomes, as I'm coming from the left, I'm going to negative infinity. As I'm going in from the right, I'm going to positive infinity. Okay? What I'd like you to do now is I'd like you to do the same for number 2. So my domain here is all real numbers with the exception of x, I don't like that, with the exception of x cannot equal negative 1/3. My vertical asymptote then becomes x equals negative 1/3. My horizontal asymptote is I've got a degree on top of 1. I've got a degree on the bottom of 1. Those are the same. So my horizontal asymptote is y equals the lead coefficient on top, which is negative 2, divided by the lead coefficient on the bottom, which is 3. So I get y equals negative 2/3 there for my horizontal asymptote. Okay? So then we've got end behavior. As x is approaching positive infinity, f of x is going to negative 2/3, and as x is approaching negative infinity, f of x is going to negative 2/3. I just have to figure out now which one it's going to. Okay? Alright? So if I'm looking at this, my function again was this one, 5 minus 2x over 3x plus 1. So if I pick some big number, like 100, let's say. Okay? So if I pick a hundo, that's going to be 5 minus 200, which is negative 195, over 300 plus 1 is 301. Right? I just picked 100. I substituted x in. Okay? Alright? So, if I do that, that's going to be 195 divided by 301. That's going to be negative 0.64, which is on the above side of negative 0.66. Okay, because 2/3 is negative 0.6 repeating, so this is coming in from above. Now, if I do negative 100, then this is going to be 205 over negative 299, which is going to be negative 0.68, which is in the bottom side of negative 2/3. So that's coming in from below. Okay. Now I've got to do some asymptotal behavior. So as x is approaching negative 1/3 from the left, what is my function doing? And as x is approaching negative 1/3 from the right, what is my function doing? Okay, so now I'm looking here at negative 1/3. So if I pick a number to the left of negative 1/3, like, I don't know, negative 1, okay, so I put that into my function. My function again was 5 minus 2x over 3x minus plus 1. Yes, 3x plus 1. Okay, so if I put negative 1 in there, I get 7 over negative 2, which is negative 3.5. So that one is going shooting down to negative infinity. Okay? Because my function was over here, from my end behavior, as I was going to negative infinity, I was coming down from here, and then this one puts me there, so that has to make that curve down. So it's curving down to negative infinity. On the other side, I was above, if this was my line, negative 2/3, I was above here, and so a number to the left here would be, or to the right would be 0. If I put 0 into my function, I get 5 over 1, which is 5, so this function has to curve up, so it's shooting up to positive infinity. All number sets. Okay? Knowing numbers to plug in, knowing when to hold them, and knowing when to fold them. Okay? Okay? Try these two. Okay? Don't have to find find asymptotal and end behavior, just finding asymptotes. Okay? Okay, just finding the domain of the first one. All real numbers, but x cannot equal -1, which then means I have a vertical asymptote of no, -1's a number. X equals -1 is a line. Okay? Must be stuck in a. I don't like it. Just that. Let's go. There we go. Okay? Horizontal asymptote then. Degree of the top. Degree of the top is 2. Degree of the bottom is 1. So top is bigger. So that's a none case. Okay. Number 4, domain. X cannot equal plus or minus 3. Vertical asymptote. Can I write them together? Because they're two separate lines, so I can't write them together. Okay? Degree of the top. The degree of the top is 2. Degree of the bottom is 2. So that's the same. So NQH, the horizontal asymptote is? Y equals 6. What if I put 6 over 1 there? That's okay too, because that's following the pattern. Yep. Questions on those two? We take the lead coefficients of the top and the bottom, because the degrees are the same. So the lead coefficient on the top here is 6. Lead coefficient on the bottom is 1. 6 divided by 1 is 6. Or I would also accept y equals 6 over 1. I would not accept it if you just put 6 there. Okay? Got to be in line form. Okay? Try those two. Domain. Which means then that my vertical asymptote is x equals 0. Okay. Degree of the top, 3. Degree of the bottom, 1. Top is bigger, so that's a none case. Okay. 6. Domain. Can the denominator ever be 0 here? No. Okay. So that just means it's all real numbers. If there's no restrictions, then there's no vertical asymptote. What's my horizontal asymptote? Y equals 2. Degree on the top is 2. Degree on the bottom is 2. That's the same. So I look at my coefficients. Okay? Formative tomorrow. Quiz on Friday. Note cards are just being developed like it's going out of style.